It's 2 a.m. Your fraud detection system just flagged something suspicious, but your Snowflake warehouse autopaused at midnight to save costs. You're now watching a loading spinner for 45 seconds while it spins back up, then another 30 seconds for your query. By the time you have answers, the transaction has already propagated. This scenario plays out hundreds of times a day across finance, security, and data teams. The problem isn't that analysis is hard. It's that the infrastructure to run analysis has become a bottleneck: cold starts, per query costs, auth handshakes, managing yet another service. What if you could analyze millions of rows on your laptop as fast as you can ask a question? DuckDB is an embedded SQL engine that runs directly inside your application. No server, no network, no spin-up time. Combined with an AI agent that understands plain English, you get analysis that's faster than anything that came before. DuckDB uses a technique called vectorized execution. Instead of processing data one row at a time like traditional databases, DuckDB groups millions of rows into chunks and processes them at the speed of your CPU's native instructions, 4 to 8 values per cycle using SIMD. That's why summing 10 million integers takes milliseconds, not seconds. DuckDB reads Parquet files, a compressed columnar format, directly from disk without unpacking them into an intermediate representation. A 5 GB dataset that would take 30 seconds to load into a remote warehouse loads and filters locally in under a second. The second half of the equation is AI code generation. An agent takes your natural language request, find all customers who spent over $1,000 last month, and internally reasons through what query you actually need. It generates the SQL, executes it, and interprets the results without you ever writing a line of code. The old way: request analysis from a data analyst, wait for the Slack response tomorrow, find out you asked the wrong question, start over. The new way: ask your AI agent directly, get results in seconds, iterate until you have the insight you need. Let's walk through real use cases where this changes everything. In fraud detection, security teams run batch analysis each morning. Now imagine analyzing millions of transactions in real time as they flow through your system. In incident response, when services fail at 3 a.m., engineers ask show me all errors in this service between 2 and 3 a.m. grouped by root cause. An agent scans 500,000 log lines and surfaces answers in 2 seconds. In ML feature engineering, data scientists iterate on features 20 times. Each experiment on 10 million rows now runs locally in seconds instead of waiting for Spark jobs. For SaaS analytics dashboards, teams stop pre-computing cubes hoping they match customer questions. Instead, you compute at query time. Run ad hoc cohort analysis on 2 million users, slice by 5 attributes, calculate retention, all in real time, all for free. And in security operations, threat analysts hunting across 50 million endpoint events can ask find all machines that contacted the CNC domain and downloaded this file and get answers in seconds. But we need to be honest. DuckDB is optimized for analytical queries on datasets up to roughly terabytes, not petabytes. If you need sub-millisecond response times across thousands of concurrent users, a distributed cloud warehouse might still win. And if your team's bottleneck is domain expertise, not speed, an agent won't fix that. DuckDB also requires your data to be accessible on local disk or fast network storage. If your data lives locked inside a proprietary cloud warehouse with no export, this approach doesn't apply. But here's the real unlock. When speed and cost align, teams stop asking can we afford this analysis, and start asking what questions should we ask? Sub-second latency on million-row datasets. Zero infrastructure costs. The ability to iterate on analysis as fast as you can speak. That's why DuckDB and AI agents are quietly reshaping how teams think about data, not as a separate, expensive resource, but as a tool as accessible as a search engine.